Hello and welcome back to Curtitus Math. This is video number 6 in the video series that are the preparation videos for science option secondary for math. This video is covering perfect square trinomials and it relates to questions number 43 to 50 and number 51 to 62 in the preparation package. So perfect square trinomials are not very difficult to deal with. It's really just what we call remarkable identities. So it's kind of a bit of a special case, similar to a difference of squares, but not a special case that requires any like special techniques to deal with. When we saw difference of squares, that needed us to know what to do when we saw a difference of squares because there is a very specific way of breaking it up. A perfect square trinomial, you can just use product and sum. There won't be a problem with that. You'll get the right answer, but there is a little bit of a shortcut if you are able to recognize the remarkable identity, and it might be a little bit quicker to deal with. So what a perfect square trinomial is when you have a binomial that ends up being squared. So one example could be something like 2x plus 5, and that gets squared. So if you remember what happens when we have a square here on a binomial, you're not able to just distribute directly like this. That's not good. You can't do that. So you do actually have to expand it out. Oops, there we go. So when we expand it out, it becomes 2x plus 5 times 2x plus 5. And then you would have to go and either FOIL or do your long level 2 multiplication depending on what you learned how to do. So I would do it like this, step by step, and you end up with 4x squared plus 10x plus 10x plus 25. So at this point, you'll realize that what we ended up with here in the first term is that we got exactly the first term we started with, and it's all squared. So the 2 got squared and gave us 4, the x got squared and gave us x squared. And then at the back end here, we have our last term, our 5, and that got squared and gave us 25. And then this middle component, so here I'll just start color coding these. So here, and then this middle situation, we have two 10x's. So we have 2 of our 2x times our 5x. Or just 5, not 5x. So that's what happened here is we got exactly 2 of these multiplications, 2x times 5. And then that ends up being totally simplified as 4x squared plus 20x plus 25. So that's what a perfect square trinomial is. It means that this trinomial came from a binomial that was squared. And if we were to generalize this, so instead of actually putting in an algebraic expression here, I'm going to give it a very general, just a plus b, any number a, any number b. They can be, these two terms can be anything. A can be 2x, it can be 3xy, it can be whatever it wants to be. We just have this a and this b, and they get squared. So if we write this very generally, like this, we can see, kind of give us a formula of sorts to go off of to see what happens. And here you'll see we'll get a squared plus ab plus ba, which is the same thing as ab, plus b squared. So we get our first term, a, gets squared. Our second term is 2 of a times b, and our last term is b squared. So that's exactly what we had ended up with here. we have our first term was squared, our second term came from 2 of our first and second terms, and then our last term was our 5 that got squared. So this is a positive perfect square trinomial, so it's the square of a sum. You can also have the square of a difference. So if instead of a plus b squared, you have a minus b squared, it ends up being almost exactly the same thing. So we'll see what happens there. So here we get a squared minus ab plus b squared. And it's plus b squared because we have minus b times minus b. That's going to give us a positive. So it ends up being a squared minus 2ab. So the only difference when you have a square of a difference, a square of something that's being subtracted, it's the exact same thing except that second term is now negative instead of positive. So when we're going backwards from something like this, again, you can use product and sum to do it. But if you get very good at recognizing these, and in the questions here, so we're going to look at these two that I circled. Because I'm telling you that they're perfect square trinomials, then you can use the shortcut method. So all you have to do is figure out what are the two things that are in the binomial that got squared. So you only need to look for that first term and take its square root. So here you're doing the square root of 16r squared. You get 4r. So that 4r is going to go in the first spot. And then you're going to take the square root of the last term. So, the square root of 9, we get 3, and that 3 goes into the last term in the brackets. And now all you have to do is double check this middle term. So here you have 4r and you have 3. So we're just going to check that 2 times 4r times 3 does indeed give us 24r. So 2 times 4r gives us 8r, times 3 gives us 24r. We're good. So this would be your perfect square trinomial. You can write it like this with the square. You can also write it as 4r plus 3 times 4r plus 3. So you can do it this way because I'm telling you that they're a perfect square trinomial. If you don't really like this, you can also do product and sum and you will get the same answer. Okay, now for number 47, this one is a little bit more involved since there's more going on in here. Generally, we don't have multi-term expressions like in, you'll need to know how to deal with this, but they're not as common in problems later on. So here again we only need to really focus on the first term and on the last term. So the first term we're doing the square root of 16x squared, which is going to give us 4x. That's going to go in the first spot. And then I guess I'll do this one in blue instead. And here we're going to do the square root of 9y squared. So that's going to give us 3y. And that's going to go in over here, 3y. And then we need to do our double check. So check 2 times 4x times 3y, 2 times 4, that's 8x, times 3y. That gives us 24xy. And that's exactly what we have here. So it's all good. That is really all there is to perfect square trinomials. The only thing that you would need to watch out for is to check if this middle term, if it's a plus or minus. So that's going to tell you what the sign is over here. So if we actually looked at, we'll take a look at 50. So here, because you have a subtraction in the second term, you know that your binomial is going to be something minus something squared. So now we can do the same thing for x squared. We take the square root of 4x squared. That gives us 2x. That goes in the first spot. Same thing to the last term. We take the square root of 25y squared. That gives us 5y. We put that in the second spot. And then we check this over here. If we do, so check, we do 2x times, and now because we put this minus, we're doing times minus 5y. And then all of this would be times 2, so 2 times. So we have 2 of these. We'd get 4x times minus 5y, 20xy. And that is exactly what we have here. So that second term is what's telling you if you're doing a subtraction or a addition within the binomial. Okay, so that's really it for perfect square trinomials. They are quite nice to work with. I could also show you, I'll also show you the area model of what it means to do a perfect square. So we'll use 2x plus 5. So if I write 2x plus 5, and I actually draw this out, so I give this a length. So if I say that this here is 2x, so we can actually break it down into an x and an x. And this over here is 5. And then I take this whole thing oops, come here, and I multiply it, right? And multiplying is what you do when you do area. So I also have this 2x plus 5 on this side. If I was to now draw some lines and make nice little boxes, so I'm going to box this up. You see that I'm getting a nice square. Okay, so this is the spot. I'll line this up nicely. So where I drew these lines is where I have the addition. So this is the spot where things get added up for this first expression and for this second expression. So you can give each of these areas, you can do that multiplication. So here we have 2x times 5 in this first box, and so 2x times 5, we get 10x. In this nice little perfect square, we have 5 times 5, and we get 25. In this nice perfect square, we have 2x times 2x. 2x times 2x, we get 4x squared. this nice perfect square. And then in this last section here, we have 5 times 2x, and we have 10x. So this is another way to visualize what's going on when you multiply binomials. So you can always use an area model if you want to, if you like it. And it's just so that you can see why we call it a perfect square, is that the two sides of this shape that I made, they are the exact same length. They are both 2x plus 5, 2x plus 5, which means that they are making a square. And within that, we can break that up into one perfect square, another perfect square, and then these two rectangles that fill up the rest of that shape. Yeah, and then to put together your total trinomial, you would just take the area of all of these squares and you add them up. You go plus 20x plus 25. So that's the area model. If you don't like the area model, if you watched all of this and you're like, well, I don't really like this, I don't know what's going on, then don't worry about it. Just do product and sum as you've been doing. You can take the square roots like I just showed you. And if the area model helps, then you can absolutely use that as well. Okay, that is it for perfect square trinomials. If you have any questions or if you want any elaborations on anything that we've covered up to now, you can always drop a comment in the comment section. If you need any help, feel free to go ask your math teacher, or you can always drop by the math office. All right, I will see you in the next one. Bye-bye.